subtracting rational expressions. How do you add and subtract rational expressions? Well, just like with fractions, you have to have a common denominator. Example, 1/2 plus 1/3. Common denominator would be 6. Okay, 2 goes into 6 3 times, so that would be 3 times 1 give you 3. 3 goes into 6 2 times. 2 times 1 would give you 6, or 2 times 1 would give you 2, and then 3 plus 2 is 5. And so to do it, you have to have a common denominator. Same thing with rational. Same thing with rational expressions. You have to have a common denominator. So the process is very similar. You convert to like denominators. Step 1, convert to like denominators. Like denominators. Step 2, add or subtract. Add, subtract. The numerators. And then simplify. Simplify if possible. Identifying excluded values. Given a rational expression, identify the excluded values by finding the zeros of the denominator. If possible, simplify the expression. So what do we got here? The denominator of the expression is x minus 1. Since division by 0 is not defined, the excluded values for the expression are all values that would make the denominator equal to 0. So x minus 1 equals 0. Add 1 to both sides so you get 1. Begin by simplifying the expression by factoring the numerator. Okay, so x minus 1 minus x squared, that would be 1 minus x and 1 plus x. Divide out terms common to both the numerator and the denominator. So 1 minus x times 1 plus x. And then you got 1 minus x and 1 minus x. So that's going to give you negative, don't forget your negative there, 1 plus x, which gives you negative 1 minus x. The simplified expression is 1 minus x squared divided by x minus 1 equals negative 1 minus x. Whenever x is not equal to, and that's back up there, when x is not equal to 1. What is the domain for this function? It's going to be all real numbers except for x cannot equal 1. Remember up there, 1 made it 0. What about its range? Well, it looks like it's going to be all real numbers, but remember, this can't be 1. So what did you have up here? Let's see here. We'll do this. Negative 1 minus, and then that 1 there, the 1 here. That's going to give you negative 2. So what is the range? The range is going to be all real numbers except for y cannot equal negative 2. There will be a hole in the graph at negative 2. What factors can be divided out of the numerator and denominators? The only ones that can be divided out are common factors. If you have the same thing in the denominator that you have in the numerator, those will cancel out. Writing equivalent rational expressions. Okay, go ahead and read A, and when you get back, we'll do B together. We'll do B together. Glad you're back. Simplify the expression x squared plus 5x plus 6 divided by x squared plus 3x plus 2 times x plus 3. Okay, so first write the expression. And then factor the numerator and the denominator. Well, x squared plus 5x plus 6, that factors to x plus 2 times x plus 3. In the denominator, you got x squared plus 3x plus 2. That's going to factor to x plus 2 times x plus 1, and then you got x plus 3. Divide out like terms. So you've got x plus 2 here and x plus 2 here. Those divide out. You have x plus 3 here and x plus 3 there. And you are left with 1 over x plus 1. Pretty cool. Write 5 over 5x minus 25 as an equivalent expression with a denominator of x minus 5 and x plus 1. So 5, can't do anything about that. This here, we can factor 5 out, and we've got x minus 5, right? Okay, so the 5's factor out, and you're left with 1 over x minus 5. Well, it wants an x plus 1 in the denominator as well, right? So we're going to have to put that in there and keep it that. We're going to have to multiply x plus 1 in the top and x plus 1 in the bottom. And that's going to give us, the new answer will be 1 times x plus 1. That's just x plus 1. And then you've got x minus 5 times x plus 1. Cool. Got that. Simplify the expression. Okay, I guess first what we need to do is, what can we factor out of here? We can factor an x out of there, and that gives you 1 plus x squared. And here, that factors, that's a difference of squares, and that gives you 1 minus x times 1 plus x. And then here in the bottom, we can factor out an x squared, and that gives you 1 minus x to the 4th. You know, I factored, okay. And then you have x times 1 plus x squared times 1 minus x times 1 plus x, all over, and then x squared. And that's going to be 1 minus x squared times 1 plus x squared. Ooh, you know, I factored that and I didn't have to. Factored that and I did not have to. So let's fix that. And then 1 minus x squared. Okay, good. So what can we get rid of? Well, we got 1 plus x squared and 1 plus x squared. We have 1 minus x squared and 1 minus x squared. And then we have an x here, and we've got 2 there, so we take one of those out. And we end up with 1 over x. 1 over x. Good deal. Identifying the least common denominator of two rational expressions. I'll let you read that and A, and then we'll pick up with B when you get back. All right, I'm glad you're back. So what do we got? Negative 14 over, and then factor each denominator completely. So x squared minus 11x plus 24, factors of 24. So that's going to be x minus 3, and then x minus 8. Negative 3 times negative 8, positive 24, negative 3 minus 8 is negative. Look good. What about here? We're going to have x minus 3 times x minus 3. Okay. List the different factors. What we have x minus 3 and x minus 8. Taking the highest power of x minus 3, the least, well, you got two of them here, right? And you got one there. So we're going to have the least common denominator is going to be x minus 3 squared times x minus 8. When the least common denominator of two rational expressions not equal to the product of the when is the least common denominator of two rational expressions not equal to the product of their denominators? When a factor appears one or more times in each denominator. When a factor appears one or more times in each denominator. Good, good. Your turn. Find the least common denominator for each set of rational expressions. So let's take a look. We got 8 minus 24, so that's going to be 8 times x minus 3. Well, 8 can be factored some more. That's going to be 2 to the third times x minus 3. What about 10x minus 30? Let's see, that's this one here. And then 10x minus 30. Well, we can factor 10 out, so we got 10 times x minus 3. And 10, that's 2 times 5 times x minus 3. So what do we got? What do we got? Well, we got 2 and a 2. Well, we got 3 here and 1 there. So the least common denominator is going to be 2 to the third power times 5 times x minus 3. Well, 2 to the third, that's 8 times 5, x minus 3. And 2 times, that's going to be 40 times x minus 3. So that's the least common denominator. And let's go over here. What do we got? Well, 15x plus 60, that's going to be 15 times x plus 4. 15, that's 3 times 5 times x plus 4. All right. And then here, you got x squared plus 9x plus 20. The factors of 20 that give you 9 are x plus 4 and x plus 5. X plus 4 times x plus 5. Okay, so what do we got? We have 3 times 5. That's going to give you 15. X plus 4 in both of them. So we got 1 x plus 4. And then don't forget about this x plus 5 here. So we got 15 times x plus 4 times x plus 5. So that's the least common denominator there. Adding and subtracting. Well, I'll let you read all that. When you come back, we'll start on B. You have 2x squared over x squared minus 5x minus x squared plus 3x minus 4 over x squared. So it says first factor the denominators. First factor the denominators. So you got x squared minus 5x. You can take an x out of that, and that gives you x minus 5. And over here, all you got is x squared. Identify where the expression is not defined. The first expression is undefined when x equals 0 and when x equals 5. The second expression is undefined when x equals 0. Okay, so we took care of that. Good. Find a common denominator. The least common multiple for x times x minus 5 and the x squared is x squared times x minus 5. Okay, write the expression. Let's see here. Write the expression with a common denominator by multiplying both by the appropriate form of 1. So here you're going to have x divided by x, and over here you're going to x minus 5 divided by x minus 5. So that gives you x squared times x minus 5 and x squared times x minus 5. Now you can subtract the numerators, and that would give you 2x cubed, and then, let's see, that's not 2x cubed minus x cubed would just give you x cubed, and then 0 minus that would give you plus 2x squared, 0 minus negative 19 plus 19, and 0 minus 20 would give you negative 20. Good. Since none of the factors of the denominator are factors of the numerator, the expression cannot be simplified further. Your turn. Add each pair of expressions, simplifying the result and noting the combined excluded values. Then subtract the second expression from the first, and again simplifying the result and noting the combined excluded values. So we're going to add and then we're going to subtract. So what do we got here? We have negative x squared plus 1 over 1 minus x squared. This only has 1 in the denominator, and this has that in the denominator. So to get a common denominator, I've got negative x squared times, and then you got 1 minus x squared over 1 minus x squared. And I'm going to put a 1 under there. There you go. Plus 1 over 1 minus x squared. Negative x squared times 1 is negative x squared. Negative x squared times negative, that's going to be plus x to the 4th over 1 minus x squared plus, and then now you have 1 over 1 minus x squared. Now I can add the numerators, and I'm going to, let's see, I got x to the 4th minus x squared plus 1 over 1 minus x squared. And there is nothing in the numerator that's in the denominator. And so there's your answer, equals. And also x cannot equal plus or minus 1. And the reason why I say that is 1 minus x squared, that's 1 plus x times 1 minus x. Okay, so that's where I get those from. Good. Now let's do negative, do it in blue. Negative x squared minus 1 over 1 minus x squared. We're going to do the exact same thing. Okay, first we're going to get like denominators, and we already did that. So we got negative x squared minus x to the 4th over 1 minus x squared minus 1 over 1 minus x squared. I'm going to rearrange them. So let's see. Ooh, what did I do? I got negative x squared times 1. That's negative x squared. that was supposed to be plus x to the fourth. So that's going to be x to the fourth minus x squared, and then minus 1 over 1 minus x squared. Again, x cannot equal plus or minus 1. All right, let's go over here and try this one. You got 4. Might want to, let's see, this is going to be 2 minus x. That's going to be 2 plus x. Okay, so to add them, I've got x squared over 2 minus x times 2 plus x. Notice that I factored the denominator. Plus, and then you got 1 over x, 2 minus x. Well, this has a 2 plus x, so you're going to have 1 times 2 plus x over 2 minus x times 2 plus x. All right, good. Let's do the math here. You've got x squared over 2 minus x times 2 plus x plus, and that's going to give you 2 plus x over 2 minus x times 2 plus x. So now we can combine the numerators, and we're going to have x squared plus x plus 2 over 2 minus x times 2 plus x. That's your answer. X cannot equal, and that's going to be plus or minus 2. Plus or minus 2. If you set those equal to 0, that's what you get. Now, let's do it one more time, and this time we're going to subtract. So we've got x squared over and 2 minus x times 2 plus x minus, and then we got 1, and we know we got a 2 plus x over 2 minus x times 2 plus x. And maybe clean that up a little bit. All right, good. Now I don't want to write over the top of that, so I'm going to scoot this up a little bit. So we got x squared over 2 minus x times 2 plus x minus, and then that's going to be 2 plus x over 2 minus x times 2 plus x. So we got x squared minus x minus 2 over 2 minus x times 2 plus x. All right. This can be factored. That can be factored. So let's factor that. That's going to be x minus 2 times x plus 1. Over there, you couldn't factor it. It didn't matter. It wasn't in the denominator anyway. So here you've got, well, you could factor it, but it wouldn't have been in the denominator. And then you got 2 minus x times 2 plus x. And if you notice, this right here is just the opposite of that. So I'm going to multiply that top one by -1, and that'll give me 2 minus x. And then you got x plus 1. And then you got 2 minus x. And then 2 plus x. These cancel out, and you're left with -1 times x is negative x. -1 times 1 is -1 over 2 plus x. Remember, x cannot equal -2 plus or minus 2. Plus or minus 2. All right. X squared, if you took that one. Right. There we go. We're good. And it gives plenty of room. Adding and subtracting with rational models. Go ahead and read that and read A, follow along. Stop if you need to. And then when you get back, we'll do B together. B, a freight train averages 30 miles per hour, traveling to its destination with full cars and 40 miles per hour on the return trip with empty cars. Find the total time in terms of D. Use the formula T equals D over R. Okay. So let's see. He's D over 30 plus D over 40. Well, we got to have a common denominator. So let's multiply the first half by 40 and the second half by 30. And what does that give us? Well, that gives us 40, D times 40 plus D times 30. And those two, that gives you 1,200. All right. Well, 40 plus 30, that's going to be 70. 40 plus 30, that's going to give you 70 over 1,200. Those cancel out, and you got 7 over 120D. Okay. Our turn. Now it's a party. A hiker averages 1.4 miles per hour when walking downhill on a mountain trail and 0.8 miles per hour on the return trip when walking uphill. Find the total time in terms of D. Use the formula D equals D times R. So what do we got here? So T of X will equal, and then you got D, and the first half was 1.4 plus D, and the second half was 0.8. All right, good. So we're going to multiply. And then we got D over 1.4 plus D over 0.8. And we're going to multiply this by 0.8 over 0.8 times. And this will be times 1.4 over 1.4. That will give you 0.8D over 1.12 plus 1.4D over 1.12. Combine those two, and you get 2.2D over 1.12. Put that in the calculator, and you get 55 over 28D. Pretty cool. Yvette ran an average speed of 6.2 feet per second during the first 2 laps of a race, and an average of 7.75 feet per second during the second 2 laps of the race. Find her total time in terms of D. So D would be like 1 trip around. So time, T of X, will be, she ran 6.2, well, that would equal 2 laps and 6.2 plus another 2 laps at 7.75. Okay, so we got 2D over 6.2. We got to get that 6.2. We got to get that common denominator, and we're going to multiply that by times 7.75 over 7.75 plus 2D over 7.75 times, and then 6.2 over 6.2. Okay, what does that give us? What does that give us? 2 times 7.75. That should give us 15.5 D over, and then 6.2 times 7.5 should be 48.05 plus 2 times 6.2 should be 12.4 D over, and again, you should have 48.05. So if we add those, that's going to give us 15.5 plus 12.4 should give us 27.9 D over 48.05. Put that in your calculator, and that's going to be approximately 0.58 D. 0.58 D. All right. Good. Why do rational expressions have excluded values? Because you can't divide by 0. You cannot divide by 0. It is undefined. How can you tell if your answer is written in simplest form? The easiest way, or the only way really, is if none of the factors in the denominator can be found in the numerator. Uh, 13, essential question check-in. Why must the excluded values of each expression in the sum or difference of rational expressions also be excluded values for the simplified expression? Well, you cannot add or multiply, you cannot add or subtract. You cannot add or subtract undefined expressions. So any values that makes one expression a sum or difference undefined has to be excluded, has to be an excluded value in the simplified expression. Great lesson. Enjoy your evening, and I will see you tomorrow in school.